Boop. Let's put that over here so the people can see. One second. Okay. I think we're about ready to get started. Right. Okay. Somebody just remind me about the T in a little bit. Anyway, this is a question and answer session for people who are in the programming language beta. Of course, the stream itself is not security protected. Anybody is welcome to watch the stream, and in fact, we'll probably put it on YouTube. But the primary purpose is to answer the questions that the people using the language have, as opposed to, questions from people who are curious and not using the programming language. And so the main question channel is going to be the Discord channel for, that we use sometimes. I should have I didn't even, because I'm so busy lately, I didn't even send a notification out of this out to the email list. So the only people who are going to be here are people who are on Discord or who saw the tweet. So that's fine. We can do another one later that is more rigorously planned by me. But anyway, so if you're in the beta and you're watching, you can go to the Q&A thread on the Discord channel, and that is where you pop questions in. And that is pretty much the preamble. So maybe there's important, pertinent information I've forgotten to give. We'll figure that out as time goes on. Okay, so first question. How does a compiler determine what goes into the executable with regard to compile time execution? If you're reading a file when using a run directive and do some processing on the file to calculate some constant to be baked into the executable, how can you ensure that the intermediate steps and the loaded file aren't included in the binary? Yes, that's a very good question. So right now, this is something that I've been thinking about adding a directive to change, because that would have a few effects, which we'll talk about. But right now, the answer is you don't really. The answer is those things just end up in your executable. Unless, well, right, that's what the whole workspace structure is for partially, right? Is to maintain hygiene between compile time executable code and runtime code, right? You have one workspace, import tons of modules that you don't want the runtime code to have to think about or whatever, right? Now, The downside of the separate workspace thing is just it's structurally a bit more work. If you didn't want to have to do that for your program, well, then it's nice to not do it if you don't have to do it. And the other thing is, maybe sometimes it's just more convenient to do the things you want to do, like so-called on the ground inside the target program, right? I had the beta notes just on the screen from working yesterday. I wonder if there's something more useful. If there's not, I'll make my camera a little bigger if I can figure out how to select it in the new OBS. All right. I don't want to be too big. It's morning for me. I was up late last night. Okay. So obviously what we can do, right, is add a tag on a function, like a directive that just says compile time only, right? That there would have to be some associated checking with that. Like you can't call a compile time only function from a non-compile time only function, or maybe it'll fault. Like maybe we allow that because it's convenient in some cases and maybe it'll fault, right? But then that function would definitely not go into your executable. And because it wouldn't go into your executable, the thing about that is it changes the semantics of what we could allow you to do, because there are things at compile time, like we happen to know that if we're doing compile time execution and you have certain data types that we know certain information about them, right? So it's just, I think it remains to be thought through, all these details about how this should work. It's definitely on the list, but the thing is, because it's just a little bit more of an optimization than core functionality, it's been a little bit further down the priority list, right? Like core functionality, I think, well, robustness and reliability, right? Expanding core functionality, and then, like cleanliness, in general, there's this issue, right? Part of the whole overriding mission of this project is to deal with the disaster that software has become in the greatest way that we can, right? Or to the greatest extent possible. And you don't do that by adding more garbage into the garbage pile, right? And so it's actually pretty important for us to continually do our best to avoid throwing more garbage in the garbage pile. And so that is a priority, but it's also it's like a medium to longer term priority, just because the way that I like to make software is just draft it out and then make it solid later. Like that's what I've found works for making things that are really complicated. And so that's what we've been doing in that department. And so, that's why features like this that are like, let's make the executable as clean as possible, are prioritized for a little bit later, because it's like, that's just the style. We're still not, as maybe you've seen if you read the beta notes or in the Discord, we're still not clean of libc. I mean, we can't be clean of libc in Linux because of Linux, but on Windows, we're pretty close at this point, but there's still a couple of things. And why aren't we? Because like I said, if you're trying to reduce the size of the pile of garbage, relying on the runtime language that was designed in the 1970s for a completely different programming language is not very good. But the fact is that we knew we could remove it later, right? And we just prioritized other things. And so, yeah, that's the style. But it's on the list for sure. Okay. How do we do follow? Let's, when I do a question like that, we could give a few seconds for follow-ups. I don't know how long to wait. Like, it takes a while to type things. If you have a follow-up, people can do it. You know what? I'll go to the next question, but if you have a follow-up, I can do that after this, just to try to keep things somewhat contiguous. Any plans to further automate the creation of wrapper modules for system calls at user level beyond or extending bindings generator? I am not sure what would be good to do there. And so the answer for me personally is no, I don't have plans. But if there are things that would be good to do, we should talk about it. If it were all up to me, like here's the thing. I personally, my personality is that I don't like tools and I just bang my way through things. And so if I were making this programming language just for me, there probably wouldn't be bindings generator. I might have some like editor macros where I try to turn C++, into bindings in a low quality way. That's actually what I was doing in the beginning. And that doesn't scale very well, but I would just put up with that. But, because it's a programming language for lots of people, we try to do this kind of thing. And so the bindings generator, I think, has been really helpful. But yeah, I don't know what else you would do, I guess. Maybe other people know. Okay. Bit of a basic one. I seem to generally rub up against type inference of number types and end up with a lot of casts. Interesting. I don't, I'll say. I hardly ever have number casts, but let's see. So understanding how the compiler handles that internally might help. Some of them are provably required to be a certain type, but a cast is still required. Situations like for loop, when you want it to be a specific number type. Yes. Right. In a for loop, you would cast like that. I almost never do that because I usually don't care about the type of the iterator. In fact, I don't even very often use numeric range for loops like that, which might be the start of this. So because I obviously don't end up casting them very much. So that might just be a style difference. Let's see. Example, U8 equals if x. Let me paste these examples where people could see them. That'll make us a little more visual. Okay. So these are examples of casting, right? And then U8 equals if x some condition, then cast U8 0, else 255. Yeah, this is a little bit of a different case. We'll talk about that in a second. Yeah. Okay. So these last two are sort of covered by the same thing, which is the following. In order to keep things very simple, right, type inference is unidirectional, meaning that it flows from the leaves of the syntax tree up to the root. There's a how-to in the documentation that discusses this, right? But we'll recap it for a little bit. But you can, just for people who have questions or want more detail, you can look there. There's two reasons for this. Again, three reasons. One is speed. Two is so programmers can understand it and not rely on magic or feel like they're relying on magic all the time. And then when something goes wrong, they're like, I don't know why it doesn't infer, right? And three is to avoid spooky action at a distance that breaks your program. Like back in the day, in like the 1990s, when I programmed in old-fashioned languages like standard ML. ML has very aggressive type inference, and you could change something in a function and it would break something, 3 functions away, right? And debugging that is really not fun. And so, early in the design of this language, I decided that I didn't want to have those problems, and that, so therefore type inference would work this certain way, right? And so the reason you need casts here is because there's no way, like, the types need to go from here up to here, right? And from here up to here. They don't, like this can't impose a cast downward, right? Now, the reason in a case like this, if you say mask equals 1, right, that works because these are like peers, right? And for binary operators, we do a peer-to-peer type checking, right? But as soon as they're hierarchically different, that doesn't work. Now, what else I will say about this is that it is obviously annoying in a couple of cases, right? I get annoyed by it sometimes. The if-x thing is a big one. Not even necessarily in cases like this, but with anonymous enums, right? So if you have something like this, you have to, you want to say like apple else banana, right? But you end up having to say some kind of fruit. I can't type right now. What's going on with a long name, right? That's pretty annoying. So these are the, you don't have to do it on both, but you have to do it on one. And the reason for that is because, again, the type check has to happen among these peers and then flow up. Now, what else I will say about this is that I wanted to be very conservative about it in the beginning because, again, I had seen this problem in all these languages with aggressive type inference. And I didn't know how it would go to do things this way. So I was like, we're just going to do a very solid, simple, smooth brain type inference and see how it goes. And now we've got a bunch of time seeing how it goes, and it's fine, and we don't have those problems that you have in those other languages. And so I'm looking at adding some special cases, right, for like retro type flow. And those are these exact cases, basically. So like, I'm looking at making it such that if you have a binary operator or an if-x, which is essentially a binary operator, it's a little different. Simple if-x, yeah. But I'm going to look at making type inference flow the other way in those simple cases and just see how it goes. Now, the thing is, I don't want this to slow down the compiler, right? Some languages made, for example, by Apple are very, 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 very slow to compile because they do all sorts of combinatorics to make things work, right? Like maybe this will type check, maybe this will type check, etc. And we don't do that. Pretty much never. And so we just want to avoid that kind of a situation. And so I just want to make sure that that's true. Now, in some of these cases, it's much more obvious that we would avoid that situation. Like here, we actually can do the type checking the way that we normally do, right? So if I delete this, this actually has a type internally to the compiler. It's called anonymous enum, right? So what we could actually do is propagate anonymous enum up, which is what we do right now, and then compare that to A. And if we're comparing against anonymous enum and it's a known type, then flow it back down, right? Now, number types is a little bit more, it's just a little bit more general than that. It's like less specific of a case. And so I would have to look at it and think about, do we end up inadvertently causing any of this kind of like runaway, recursive, speculative type inference? And I don't think so, but I'm not sure yet because we haven't thought about it. Here's a meta question, not a Zuckerberg meta question. How do people feel about this level of detail in the answers? Is it too much or is it okay? I don't want to do more because then we'll be here for a million years. We're already, half an hour past the start time of the stream. So let me know if you want less detail or if this is fine. What is the difference between a type info and a type internally? What happens behind the scenes if you cast them? What are you allowed to do? Okay, so this is another area where in the beginning I was being conservative, and then well, okay. It seems mostly fine. I would characterize the situation with types and type info as I would like to make it a little bit simpler if possible in order to expand power and functionality. And so I'm looking at that. But anyway, so what's the difference between a type and a type info? If you compile with default settings, there's not really a difference. A type, if you have something of type, right, a value of type, what that really is a type info pointer, and you could cast it and use it. Now, the reason that we don't just declare that that's how it works always is because we have this settings in build options. If I go there, runtime storage list type info, which hopefully you can see, yeah. That one. And what that does is says, hey, I'm running on an embedded system or something, and I don't want to store all this static data for my types. So please don't do that. And in that case, if you have a type, it does not cast a pointer to type info. It's just essentially a number. Now, once you do that, a lot of features go away, or you can't. There's a lot of information you don't have because you don't have those type info pointers, right? And I'm not sure actually how many people are really going to use this. So if we take it out, then we can clarify the situation around type and type info. But for right now, the reason that they're different is for potential efficiency, right? And also, I think there's a mental thing of, when you say pointer to type info, that's just a different kind of a thing than a type. I don't know. So we might still keep that dichotomy, but still make it, clarified that they're the same. I don't know. Feedback on whether you want this or whatever, use it would be useful. This is one of the first, when I initially put in the type info, I put this in, again, to be conservative about performance, but I'm not sure how many people are ever really going to care about this now that we've got some water under the bridge on it. Like, I certainly never think about turning it on, but, I don't do embedded system stuff. But again, also, like the type info, it's not that big, right? So, yeah. One other reason to keep them separate, to keep type separate from pointer to type info, is anybody could make a pointer to type info. Like it's just a pointer to a struct, right? You could make it at user level and fill it out and do stuff with it. But that doesn't correspond to a type that the system knows or that is in the program. And so that's another reason why they're two different things. So you could think about it as being very clean to go from type to pointer to type info. But if you cast back, that's not really that useful of a thing to do because the system, there's not that much you can do with a type at runtime, right? At compile time, you could cast back and use it in certain ways, but at runtime, there's just not that much you can do. I mean, it's essentially an enum value at runtime, right? So I'm not sure that's a thing people do that often, but you could imagine when casting back. So if you cast back from a pointer to type info that you just made on the heap or something, then you're calling it a type, but it's not really in the space of the other types that the program knows how to deal with. And, it's just not a clean thing to do. During compile time execution, there are certain compiler functions where if you call them, they expect it to be a type generated by the compiler. And so if you make a pointer type info and call one of those with a type that's not a real type, the compiler will get angry at you. Okay. Sure, this has been asked before, but are there any plans on actually possibly embedding the compiler itself into a compiled executable, or at least the interpreter part of it? Could be a super cool feature that allows for the kind of eval function. Yeah, I mean, that's been vaguely on the roadmap for a long time, since the start of the compiler. The thing is just, it's kind of a low priority because I mean, making the compiled language as good as possible is the highest priority, right? And yeah, I just don't want to do things that slow that process down. Like, yeah, it would be neat to call a function that compiles some code and then lets you call it, right? And it might not even be that much work. Like all we have to do is make a library version of the compiler. It's just that's another compiled target that we have to maintain for each operating system and all that. And I just don't want to add that level of friction right this second. Although, you know, we recently increased our level of automation a little bit on the builds. And so, you know, that makes that a little bit easier. Yeah, I don't know. The other thing I feel about that is just you have that in all these other languages, right? Especially the dynamic languages that are interpreted anyways. And so when looking at what to be inspired by or what features to prioritize, I think that you not only look at what other languages do, but you look at whether it's a good idea and like how much are they actually solving hard problems via those features. And, you know, the fact that you can do eval, I'm not sure it's really that useful. Like when I'm working on, you know, a video game that's hundreds of thousands of lines long, I don't care about eval, right? So that's just why. That's why it hasn't been like if I was still a couple years out of college and still drinking the Kool-Aid, that would have been a much higher priority, right? But yeah, it's not necessarily that hard. There are certainly issues that are along the lines of the kinds of issues that we have that we're currently addressing with regard to DLLs and stuff. So for example, you know, you have a type table and the code you just compiled maybe uses some new types. What do you do? In a library version of the compiler, though, you could pass the existing type table in and like extend it somehow. I don't know. So yeah, it just I'm not personally excited enough by that to feel like it is worth the amount of added complication at this time. But it's basically guaranteed to happen eventually. It's just a question of when eventually is. Okay. Do you have a plan for how this language can be used for web development? You know, I don't care about web development at all. Like literally, and part of this is just a personal thing. I've just seen software turn to complete trash during my lifetime. It was bad when I was growing up, and now it's just complete trash, right? And the web is responsible for a lot of that. I don't think for too much of an inherent reason. I mean, part of it is just that that's when programming blew up so fast, and part of it is that we made some very poor aesthetic choices about programming languages that were timed for when the web blew up, and that formed what JavaScript was. And JavaScript could have been something very different, and we would be living in a better world today. Software would still be bad, but it wouldn't be as terminally horrible as it actually is right now. So I'm not interested in web stuff personally. But if other people are, I certainly don't, that doesn't bother me. And in fact, it's great if people want to do web stuff with this language, because it is an actual fact that many, 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 many people out there in the world interact with the web on a daily basis. And so if you can improve that or do interesting stuff there, you make things that impact the experience of a large number of people. And so, yeah, I mean, if people want to do stuff that makes web development better, that's great. That is not personally what I think about when I wake up in the morning. Right. I'm just worried about large programs and complexity and dealing with that, broadly speaking, which does affect, web style programs as well as system style programs. So that's really where my brain goes when I work on the compiler. But yeah, my answer right now would be to sort of leave it up to users. Like, you wouldn't want me to design modules to help with web development stuff, because I hardly do any of that. I haven't written anything that runs on the web since, I'm guessing, I'm going to say 2006, something like that. No, that's not true. Maybe it is true. Maybe 2009. I don't know. Something like that. I mentioned a couple of times I was thinking of reworking how macros work. If that's still the case, how so? I don't know specifics yet. Okay, I can tell you some general things, right? A lot of the things that we experimented with, or that we have done so far, were experiments to see how it goes, okay? Because the broad level idea about macros was like, hey, you have languages like Common Lisp that use macros to transform code in a relatively easy way. Now, the downside of Common Lisp macros is they're very complicated to understand, and when there's a bug, everybody is very sad because it's hard to figure out, right? And so part of the thesis was, okay, maybe type checking helps with that. And then part of the problem statement, though, is the following. The reason Common Lisp can have a powerful macro system like that is that the syntax is so flat, right? Like, the macro system operates on lists. And, if you go to college, they'll tell you how wonderful all this is, right? The problem is that it means you have to program in that flat syntax all day, which isn't great. Now, part of the experiment that we were doing here with the macro system was, okay, just what does it look like if you actually have a non-flat syntax that has all these specific nodes like a C-style language does, and if you just do the work required to let user programs view that and manipulate it, and what happens? And I don't even think we've done 100% of that work yet, because we sometimes run into stuff where we're like, oh yeah, that just doesn't work right, or we don't know how to do that. But we're getting there, right? Now, so that was one part of the experiment. And another part of the experiment that's sort of orthogonal to that was, let's make macros hygienic, right? So that you can write them like a regular function. And let's have them act like a regular function in every way, right? Like a macro overloads with non-macro functions, right? The idea then was, hey, we'll use the backtick, which is mildly inspired by Common Lisp syntax, but not really, because it means something different here. We'll use that backtick to, do a scoping alteration, right? And that works okay. The backtick thing is a little bit annoying, and it's a little bit non-expressive enough, right? Because maybe you have multiple scopes that you want to talk about, and how do you pick which one? So that's not that good. And just, it's easy to forget a backtick, right? So that's actually, that's sort of a side issue, right? That it would be nice to come up with version 2 of what that is. But sort of the bigger issue then is this whole thing about manipulating the syntax tree. How do we like it? And where do we go with it? And the thing is, I don't think it's an area where we're doing enough, either in my code or in beta people's code, to really know what we think about it yet, right? Like so far, the history has been people do a little bit of macro stuff and they run into something where it's like, oh, there's no way to get this piece of information, or, you know, this thing doesn't work, it causes a circular dependency or whatever. And then I go back and fix it, and then people can do more, right? And so we've still sort of been in that phase. I would like to get past that phase, and we can just see how this whole thing actually really works. I think there would be a little bit more module support necessary for that. So, you know, like I would want to write a pretty simple like code search and replace thing, right? That's actually why a few of these other features have gone in, right? So for example, in the early days of all this stuff, we didn't have the code directive, right? So you couldn't say code f of x plus y times z, right? And so if you wanted to, like if you imagine writing a search and replace function, you either would have needed to construct manually the nodes to search for, or you have to grab it via your meta program from some exemplar in your program. And that's annoying because how do you know that you get that? Like if you have some prototype function in your code and you've got a meta program looking for it, how do you know you're going to see that before you see the thing that you want to match against, right? So things like that inspired the addition of something like this. And there is actually like a wildcard syntax that nobody really knows about. So you can do something, actually, I think it's like this. So I might be fibbing a little bit, but I believe this is a valid code directive right now. And then that could be used as a template to run. You know, you can imagine just the function that iterates over your code and looks for this and gives you back the match. This is inspired by Perl a little bit, right? So you could have 1 and, you know, 2 and whatever, and you would get back code that fills in, like here's an array of matches, and for each match, here's what was in slot 1 and 2 for all those things. And that would be cool, and that might be more expressive. But again, that's just a guess of where this might go. And I consider the whole thing to be still an experiment, and like maybe we'll delete it, right? Maybe we'll just do some totally different version of macros. Okay. What's the current policy if one encounters library code missing from the compiler library? Recently, you needed some udev headers on Linux that are not present in modules. Are we going to have a centralized repository? Okay, here's the thing. There's a question about what should go in the modules distributed with the compiler, right? And from the beginning, I decided I didn't like the C++ way. The C++ way is something like the following. Our job is to guarantee that a program written in the C++ programming language runs everywhere. And so we give you a standard library that does everything a program might ever want to do, except they somehow don't do anything you actually want to do. But like in terms of, they have this idea that in terms of data structures, they do that, even though they don't, right? And you know, it's like the communism of programming languages, right? Where you get what comes with the compiler and that's it. And from the beginning, I didn't want to do that. And the question now, so what I wanted more was like, hey, we give you some modules with the compiler and that's fine, but they don't necessarily have greater authority than anything provided by the user base out in the world. I mean, there's a couple that have to, right? The modules that are about interfacing with the compiler de facto have greater authority because it's like they declare the format of the data that has to go in or else the compiler won't be able to read it. But those are a very small percentage of the code. And like you already can replace them at user level, and we're actually going to provide more facilities for that I can talk about if anyone's curious, just to make that easier, without having to just overwrite the files. But my idea early on was just like, look, I want people to feel like, what the hell's going on? So my awesome new modern television in the other room that I just bought this year just turned on for no reason. It just like, boop, let's turn on. That's great. So what was I saying? So I would like it if there were an easy way for people to share code and just have that like be a thing. Now, what are the details of this? That's a question, because I don't like how do you make a thing that is easy for people to get code from, but it doesn't turn into NPM, right? And I don't frickin' know. Maybe there's some social technology there that needs to get figured out, right? But this was, again, the motivation for some of the stuff that was added earlier this year, I guess, if I have my time correctly, about like the module importation, right? So now if you import a module and it fails, your meta program gets a message, right? So we have that, and we have plugins. So somebody could just write the plugin that goes to a central server and download the thing. And that's why I put that there. Is that going to be horrible? I don't know. But yeah, I sort of assumed that as soon as I did that, people would get excited that they could have NPM again and just jump on it. But nobody has, which has been a little bit surprising. But also, I kind of don't mind, because again, I don't mind taking things slow and thinking them out and trying to make them not be a disaster. But definitely, I don't want to be in the business of adding things forever and ever to the core things distributed with the compiler. In fact, I would like to take a few of the things that we distribute with the compiler and factor them out, because, well, so why do we distribute things with the compiler in terms of modules? A few reasons. One is, just if you're getting started and you're sitting down programming, you have this thing, you don't have a network connection anymore or whatever, you should be able to write good programs. You should have all the information you need to know how to use the language. You should be able to write programs that do just the vast majority of what you would want to do as a beginner, which includes opening windows and playing sound and all that stuff, right? Because you have a computer that draws pixels and plays sound. But then in terms of getting more and more sophisticated and specific, it's like, okay, right, you can go out from there. But so part of it is informational. Part of it is just how much capability do you have without a network connection or whatever. But at some point, it makes sense that a lot of the stuff doesn't get distributed with the compiler. And that enables us to focus on making the core of the language good and not like maintaining all this user level code and ensuring that it works and all that stuff, right? Like that can be up to the people who are interested in that code. Can I elaborate on how poke name works? It just puts a binding into the target namespace just as if you made a declaration there. We hardly ever use poke name, and I think it's a little bit of a messy idea, and so we may just want to come up with a cleaner version of it that may be syntactically different. I think people reported a bug with it that has not yet been fixed. Does it make sense to extend the capabilities of module parameters to receive declarations and replace the need of poke name? You can do that if you want already, because module parameters could take a code parameter and insert it, right? And so you can pass a code that has declarations in it. And that would be one example of a cleaner way to do what poke name does. And in fact, that's actually an interesting example of metaprogramming, because as the module that's about to insert this code, you could scan the nodes and report errors to people of things you don't like that are better than compiler errors or something, right? Like if you're looking for somebody to add a binding for some variable and you want it to only be certain types, you could check that and complain if they aren't or whatever. When is goto planned to be added? You know, I assumed we would have added goto a long time ago. I just honestly haven't needed it. The main place it comes up is when porting C code or C++ code. And usually it's not necessary. Like the main time it's actually necessary is, you know, you have some sequence of things that you want to do on exit to the function. And you want to go to that point. That's the main use of goto. And the thing is, you can do that with defer, right? Or you can do that with a macro if like the thing that you want to do is a little bit dependent on stuff that happens later, right? You can just put the macro at every exit site. Whether that's messier than a goto or not, I don't know. But I just haven't really needed it, and that's why it doesn't get implemented yet. I'm not actually sure. I don't even think it would be very hard to implement. It's hard to say. It's one of those things where in the early days it would have been easy. And then now once you have enough stuff, anything new that you add has to work with all the stuff. But I think that it's probably fine. Yeah, we just haven't done it yet. I don't know. What I will say, I almost never want to use goto like in the game or anything, or basically never. But in the compiler, I do use it in a couple places that I don't have an easy answer for. And maybe that means those couple functions are just bad. There's certainly functions that I wish I could write simpler. So, you know, maybe I'll be motivated by that kind of a thing to implement goto. I don't know. But yeah, I don't have anything against goto. I'm not one of these people who's like goto is for bad people or something. I just haven't needed it because we have defer and we have a couple other things. You're going to ask why some code can't be constant baked in a macro. Seems like every code can bake to a constant now. Yes, with the caveat that at runtime, it doesn't mean anything, right? Yeah, that was, you know, in the last beta, we had a number of fixes that we did having to do with auto bakes and code directives and similar things. Yeah. Wow, we're still, I'm going down the questions and we're still at like 37 minutes ago. So I'll try to go a little faster. Do you think it would be useful to allow insert to insert code elsewhere and not just where the insert is placed? You have wanted to do things like use a run to generate a struct body based on struct parameters, as well as generate the bodies of related functions. Use a run to generate a struct body. Okay, so the problem with that is the following. Let's type it out so that we have something useful on the screen. You have a struct, right? I don't know, right? Something like this. And you want to generate some code based on that. One way to do it that I'm assuming you don't want to do, because you're talking about doing it elsewhere, but if I were to do it in the struct, and if I were to do it from text or code nodes or whatever, right, you would do this. You would say like insert to string or whatever, and then you put some code in here, right? I don't have auto indent because this file doesn't have an extension, right? Print, I don't know, foo : equals, we're just going to even ignore x, right? Okay, actually, you don't want to print it out. So that's how you generate code like inline. There, now we have syntax highlighting. So now to do it elsewhere, you would have to do something like this. You would have to say insert. There's two problems. One is you have to specify where. You have to say somehow into S, right? And then somehow you need to access S's parameters, even though the struct isn't done, right? And then somehow here you have to say, do not compile S until code is inserted from the outside. Because otherwise, we just decide it's an empty struct. And the thing is, you can't, like, we don't have a one and done compilation model, right? There is no things don't work like if you don't know how big S is, this is actually true even in C and C++. If you don't know how big S is, there's all sorts of things elsewhere in the program that you can't compile, right? Because they don't know how big S is, so you can't return S. You can't take size of S. You can't dereference any members. So most of your code won't compile. And so you need a way to know when you could use S in order to compile a program, right? In C, it's just like by the time you read the header file just has to say everything, right? Because we're more versatile and have a more out-of-order compilation, that's more like automated and gives you more freedom to do things. But you still need to know, right? And so any kind of action at a distance mechanism would need to solve this. Now, one basic way of solving this is like, well, I mean, that's a parameter really to the struct. So at some point, I mean, if you didn't want to pass this in from the outside, I'm going to use a very, very bad word that I hate, but it's what comes to mind, right? You could make your S factory. As soon as you start doing this kind of thing, things are maybe a little bit bad. But actually, at that point, it might as well be a function anyway. So you could call it make S, right? And then it would return something that you insert, or it could declare it directly, or something, right? But that's the thing is, you know, I've thought a little bit about this, and I don't think that the things that I think about offhand, when I start thinking about this, are worth the complexity. Like, okay. Again, this is not a troll. I've been working on the compiler a lot. It's difficult work. About half of the effort that I go into, half of the raw hours that I spend working on the compiler is dealing with nonlinear compilation bugs, right? And so I'm not very eager to make that situation more complicated. It needs to get simpler, actually, right? Because after I'm, get hit by a bus, somebody else needs to be able to make this compiler, and therefore it needs to be understandable and just as simple as possible, so that there's as little friction on forward progress as possible. So Yeah, I don't know. But if you have a specific idea about how you would like this to work, we can talk about it. It's just I personally haven't had any ideas that I like. This is related to the previous question because part of what poke name is how do you insert something into somewhere else at a distance, right? To your understanding, no reset variables can't contain allocated memory. Not true. Not true. Okay, so what you want to look at, I think we even have documentation about this, so you have to use the following thing. When you say add global data, that puts data into the executable. And then you can point to that from something that exists and we will know where it is. Now that pointer has to get remapped, so we have to know that it's a pointer. I thought I had done something where you could pass in a pointer map, but maybe that was just a thing I wanted to do and then just haven't needed to do. Yeah, but that's the function you want to look at, and we could talk about it offline. Would it make sense to pass multiple return values as multiple arguments to functions? No. People ask this, and the answer is no. And I'll tell you why. Like, everybody who's new to the language, not everybody, but it's a common question, right? So you have a function that returns multiple values. Let me delete the old thing here. And instead of print, let's take a different thing. Let's just say we have some function x, right? And then people often want to do f of 1, 2, right? And I just don't want to do that. And the main reason is because this kind of thing seems fine in the beginning, right? And it just gets messy really fast because what you start doing when you do this is you start making this webbing of dependencies through your program about all this 2-argument auto passing, and you don't see it because it's just implicit in all these calls. And then one day you want to go change one of the things and it breaks a ton of stuff in your program, right? And so so this is a seductive thing that I've seen go the wrong way in lots of programming languages, which is why I avoid it. There's lots of features in languages that are like, oh, this is super cool, right? But it only works within a very simplified regime. And then as soon as you leave that regime, which you always do eventually, it like breaks and is an annoying pain in the ass. And then you have to go undo it anyway, right? And I tend to avoid that kind of feature. So for this kind of a thing, also there's just some ambiguity here, right? Like if you start doing this, you also kind of can't have the thing where you do the C style, pay attention only to the first return value, which is actually quite useful. I do that all the time because otherwise, if you have this, like which overload gets called, like that's now an error because this is ambiguous, right? So that's kind of annoying. But the annoying thing is what happens when you have this call and somebody else gets the return of that and somebody else, like you end up passing these two things around. And the thing is, if you're going to pass two things around as a coherent unit, just make a struct out of it. It's better. Or if you don't want to do that, just assign and pass the specific. Here's the other thing, right? So the alternative to this is you just say x, y is 1, 2, which is what I do, right? F of x comma y. And the reason that I'm saying this is better is when you have a large web of this in your program and you want to change it at one point, you can just put z there and put z at the one point, and then everybody else doesn't use it, and that's fine, and you don't break the rest of your program. You don't have to go edit the rest of your program doing menial tasks just to do a simple change, right? That's what I'm trying to avoid. There was something else I was going to say about this. Oh, so in general, the other reason why I personally am against this sort of thing is like, this is the kind of thing that for some reason, when programmers have less experience, they want to put everything on one. This is not a diss. This may not be the reason why you want to do it. I'm just saying it's a thing where programmers earlier in their careers get excited by making nested expressions and putting things on one line. And the thing that sucks about this is if you're going to step through this in the debugger to understand your program, most debuggers don't really give you a very convenient place to stop in here. It's just like one line. And so now all of a sudden you don't have visibility in your program. You have to go edit it anyway and turn into this so you can see what the hell is going on. And then secondly, this is still kind of simple, but once you start, once you start making it complicated, it's like, I look at that and my brain doesn't understand what it is. Whereas if you go step, 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 my brain understands what it is. So I just want to write code this way naturally. I think it's better. And I don't want to encourage writing code this way because I don't think it's good. This is what happens when people from math class try to program. Okay? And we've all seen the results of that. It's not good. Now, if you disagree with all that, again, we can talk about it offline. I'm always interested in entertaining arguments about, why it would be better to do things a certain way. It's just some of them are very well-tread arguments, and this is one of the well-tread ones. When dealing with DLL lib output, there's a problem where the library has a different idea of what should be in the context. Yeah, we're dealing with that right now. The stopgap thing for that is there's a dynamic context in, I don't know if we have a how-to on it, but yeah, there's this dynamic context entry thing. What that means in practice is that anything that wants to be a DLL has to use those, and that kind of sucks. And so we're looking at how to get around that. If anyone has concrete ideas about the preferred way to negotiate that, that's fine. So the basic, to explain the problem a little bit more is, we have this kind of a struct that is quite useful across the program, right? And your, how do I say it, right? So what's in this context base, everybody can use, and everybody knows where it is and where the members are. But your modules that you use, or just your program, can add entries to this, right? And because they can do that, your DLL cannot see those things, or they may even happen in a different order, right? And so what do you do about that is the question. And there are various ways of negotiating this problem that have different levels of capability versus additional runtime overhead for DLLs, maybe, right? And I'm a little bit willing to, I don't like adding runtime overhead broadly speaking, but if it's like, well, in the case of a DLL referencing a context, maybe there's an extra indirection or something. I'm not that bad with that kind of a thing. I mean, that all of a sudden sucks if you decide to make your program completely out of DLLs though, right? So it's a thing that we need to talk about for sure. Okay, this is back asking about the type info thing. You're under the impression that even if this option is off, only the type infos that get explicitly referenced will be added. No, that is true. That is true. We do. Okay, so when we're exporting type info to your program, we try to minimize it by looking at what are only the types that are referenced by the program and export those. The thing is, that's still more data than you would think. And maybe that's because we're not doing a good enough job trimming it. I'm not sure. I actually need to take a look at that at some point and just see sanity check that output. Last time I sort of did a low effort sanity check of it a while back, and it seemed like everything in there was something that you need, right? But I'm not sure. And the reason is, you know, like if you take type info of a struct, right? Or let's even say you print a struct, right? To print a struct, you pass implicitly, you create an any, that any passes the type info pointer to the print function, right? And so, you know, anything now recursively pointed to by that struct goes into type info, right? And then if that has struct members, anything recursively pointed to by those goes into type info. And, you know, that ends up being a fair amount of stuff. But it is still substantially less than exists at compile time, right? So it is trimmed down. Are there any plans to make building programs less dependent on meta programs? They shouldn't be dependent on meta programs at all. So I'm not sure I understand the question. For example, setting things from the build option structure via compiler argument. No. Okay, no. Okay, here's the thing. Here's what he's saying. I'm very hardline on this. So I think if I understand the question correctly, it's like, okay, if you want to compile something with relatively specified tweaky settings, right? We give you a couple defaults, right? We give you a default debug build, a default release build. We give you some other options. But if you want to get very specific, you fill out stuff in this struct about like what, you know, do you want array bounds check or whatever? Do you want all these things? And then that goes into your program when it starts compiling. And so you need to have a little meta program on the outside that sets these settings, and then they go in. Now that is different from how it works classically with other compilers. Other compilers have a command line option for all of these things, and they actually have way more than this, right? This is very small compared to the number of options to like Clang or GCC. And then you set those. And the problem with this is the following. One of the reasons software sucks in the systems programming world, and I've given this rant at greater length elsewhere, but part of the reasons things suck is like it becomes hard to build your program at some point. And nobody knows, it's a mystery when that happens. It's like easy in the beginning, and then all of a sudden you wake up one day and it's a frickin' nightmare, and you wonder when that happened, right? Or you think it's fine, and then you try to distribute it on the internet and nobody else can build it. And this is a huge point of friction in these languages. And it shouldn't be necessary, right? Because your program, if we do take a page from the math thing, your program should be a mathematical object that is self-defining. It should have an unambiguous meaning, right? The problem is we end up doing all these things that export parts of the program into the environment. And because people's environments are different, that causes the program not to compile correctly. So to fix this problem in systems programming, you have to stop that. You have to stop exporting parts of your program into the environment, right? All of your program needs to be in the program. Now, the thing is, why is this relevant to the current discussion? The reason is because the options with which you compile the program end up determining whether things work or not, right? Like, are you in precise floating point mode or whatever, to pick a GCC one, right? Your program will break if you use the wrong one, probably. Or it'll be too slow if you use the wrong one in the other direction. That's actually bad for other reasons, right? The program text should have control over that for sub-program portions of it. But historically, those compilers don't give you that, right? So this command line option that you need to compile your program with, where does it live? The answer is in some script somewhere. What is that script? Well, it's a thing that runs some commands that passes the thing. Do those commands exist in my environment? I don't know. Is that option the same, or has the compiler been revved and they changed all their frickin' options like Clang does every 2 weeks? I don't know, right? And so all of a sudden you're saying you don't really want people to be able to compile your program if you do things that way. And so that is why your program specifies its options if you want to get tweaky. And the reason for that is that that will always work on everybody's environment. I mean, there is a such thing as options that are tailored towards specific operating systems or whatever. But those, you can give a clean error message if you try to use those in the wrong place, right? Etc. So that is the reasoning behind this. And no, there is no plan to go to more command line options. In fact, I would like to go to fewer command line options. I could show you what all the command line options are right now. I think that's the command line options, and they're mostly just for compiler developers. That is it. Now, in reality, we support more options than this. This is what the compiler executable knows, right? In reality, we have this thing called default metaprogram that supports more options. Now, going back to what we were saying before, you could replace that default metaprogram with your own. And you already can do that, like here. But we're actually, I think, I don't know, we'll see. Like I said, I want to reduce friction on that kind of a thing, broadly speaking. But that's not necessarily better than making your own metaprogram, right? So, yeah, no, there's no plan to export these things to command line options, because that's how you make software not work, is my opinion. Are you still planning on doing a rework of notes? I would like to, but it just kind of didn't totally need to happen. So right now, notes are text. If I go to an example from the Sokoban game so people would know what we're talking about. So we use them, for example, very heavily on the entities. We like mark things up. I wish this were formatted better, but you know, we mark things up about what version the members occur in and whatever. And these things after the @ sign just get passed as strings right now. And that's been fine. A long time ago, I said I want to change them to structured notes that use structs. And the reason I want to do that is because for large programs, this kind of thing doesn't scale. Because what if you picked a certain string to mean something and somebody else picked that to mean something? Or maybe there's even ambiguity. So here is like, we look for anything that starts with lowercase v and then a number and like parse that. But you could imagine that being ambiguous with something somebody's doing in a module somewhere or whatever. So I think it makes sense to be more structured about these things. We just haven't had to do it yet. And there is a little bit of an increase in friction when we do that, right? Because, I don't know, like we would have some struct locally and we would say like version. The struct would be called version 37, 45, like min and max. But that would give you the option to do a lot of parameters that are optional if you wanted to, which would be better. And you wouldn't have to do weird parsing. So it's one of these kind of things that adds more friction at the low end, but reduces friction or adds capability at the high end, right? So, you know, I just haven't been in a hurry about that. How do I feel about making the default allocator temporary allocator and making it explicit when you want to use the heap? Okay, I've been thinking about this because, so I mentioned before, we still have libc dependencies. One of those is we still call malloc from libc, which is bad for two reasons. One is the dependency on libc, right? It increases the weight of the code and the amount of complexity under the hood. The second one is that'll behave differently on different operating systems depending on, you know, what the underlying malloc is that nobody knows, right? And so it's been on the list to fix that. The reason I've been slow about it, usually when I'm slow about things, it's because there's something about it I don't like, right? If I like everything about something, I just jump on it and go. If I don't like things about some idea, I give it more time to gel and see, right? And the thing about supplying our own malloc in source code is it's now just more source that has to compile every time somebody compiles a program, probably multiple times, right? Because we compile it into the default metaprogram, we compile it into your metaprogram if you have one, and then into your program. So like we would end up compiling malloc 3 times or whatever, right? So I would like it to be small and simple as a default allocator. Now, we located one. We were going to use mi malloc, and somebody actually ported that from the beta community that we'll probably distribute with the compiler. So stepping back a minute, it is good to have, no matter what, a heap allocator of some kind, even if we were to rely on the libc one, is because libc malloc doesn't specify your ability to create multiple heaps at all, right? And you just want multiple heaps in a real program. Like you don't, the idea of a global heap, it just seems simple, but it's a bad way to do things. And as memory becomes more and more of an overriding factor in program performance, as it is continuing to do over time, and there's no reason to believe that's going to stop anytime soon, right? So there's actually several cascades of explicit handling of memory becoming more important. One of them we've already hit, which we've discussed many times, but we have a lot of people in the view, so I'll review it. It's just that cache misses are way more expensive compared to simple math instructions like an add, right? Simple to raw instructions. They're way more expensive than they ever have been in history, right? It's like 400 or 500 cycles. We have every once in a while these announcements that we're going to have faster memory sometime soon. That's been slower to happen than people thought it would be. And even if it gets faster, it's not that much faster. It's still going to be super expensive to miss the cache. That's problem number one that we have already hit. Problem number two is that we're hitting this bottleneck in CPU architecture, right? Because the only way we know how to make chips faster right now that we can actually do is to add more cores. The other thing that we know that would make them faster is to make them 3D. It's just that's a very difficult manufacturing thing to handle. And then even if you do that, you can't do it very much or you have a large heat dissipation problem, right? But that is, people are working on making chips 3D, right? And that helps you with the layout problem. But because of layout issues, right, we now have the problem where, and this is already true in retail CPUs, it's just CPU makers are doing heroic things to try to mitigate the problem and hide it. There's different distances between different cores and different caches and all this stuff, right? And so, like if you have two cores that are close to each other, messing around with the same memory, that's much more efficient than two cores that are far away from each other on the chip. All right. Now, nobody hardly thinks about that right now, except for very serious performance programmers, but that's going to become more of a thing. Like we're going to get to a point probably where your program runs way, way faster if you think about that kind of thing. And I mean, it's not like, I don't know, maybe nobody will still care. Like nobody cares right now that a cache miss is 500 times as slow as an add. Actually, no. A cache miss is like 500 times slower than a scalar add if you're not doing anything else on the CPU. But in reality, you can do a bunch of adds at the same time on a bunch of cores. So it's really you know, I don't know. That's sort of straw manning the other way, where you're saying the cache miss is the only memory operation happening, but just to straw man the other way, because people usually straw man the first way. You know, it's like at this point, 500 times 16 times 8 adds. Like, it's a lot. So, but people don't seem to want to care. So who knows, right? At some point, maybe there's just going to be a small percentage of programmers in the world, and their programs run 1,000,000 times faster than what normal programs output. That might be the reality that we end up in. Right now, that is the reality we're in. It's just a factor of 1,000 instead of a factor of 1,000,000, but it might go up to 1,000,000. Okay, enough of that rant. Okay, but to bring it back to the original question, so instead of booting up a full heap allocator when you start, okay, there's a question of what goes into the runtime versus what goes into the basic module, which everybody sort of imports. This is split off. So if you use like libc, for example, because you program in C still, or more horrendously, the C++ programming language, there's not really a distinction between the runtime. There sort of is a little bit of one if you're an internal compiler person, but like in reality, they don't get separated. And so, you know, if you call anything in the C standard library, you're accepting this entire package of runtime and whatever, and you can't really change anything about it. We have it more broken up, where there's like preload module and runtime support module, which are as small and lightweight as we can possibly make them, and doesn't include most of what you would consider being like libc in a language like C, right? And so that's in this module called basic, which, because it's easier to swap out, we don't mind putting a little more stuff in there, right? And so that's one option we could do, is like, hey, actually, the default malloc that's actually a full heap allocator that's trying to be good is in basic. And then if you boot up and you skip basic, we give you a default that's like way more minimal. Like, it could be on Windows, instead of having it be temporary allocator, it could even just call virtual alloc or whatever, like something very small, and never free anything. Like free is a dummy operation. We could do that, and that's an option. I would be interested in hearing people's opinions on what they want there. The thing is, there's a very small tactical detail, which is that we don't really have, or maybe I just haven't thought of it, there's not a very simple and convenient way to say, if you don't import a thing that defines this, here's the default operation. Because we don't have an if-def in this language, but we probably should. So if I add if-def, you could finally say, hey, if context.default allocator is defined, then do this. Otherwise, set it to this. Yeah. And that would be fine. We could probably do that with type info code. It's just, that's more code to like iterate over the members of the struct and look for the thing. And I'm just not sure I want to do it that way. But we could do it that way. Actually, that would be totally fine. So we could do this today. It would be fine. And we could swap it out later if we add a feature. So that's a possibility. And, you know, so I've been talking with someone from the beta. I don't want to dox people on stream, but you know who you are. About porting the malloc over soon. Well, we've already got mi malloc ported, right? It's just, I've been feeling that's a little bit different. If the strategy is to plug it into the default allocator, or as the default allocator at compiler startup, basically putting it here. Let me show you. Right. We would basically, so our runtime support, which is the part of libc plus CRT 0.0 or CRT 1.0 or whatever compiler you're using, however much stuff it outputs. The equivalent of that is this thing, which is 500 lines, which is a little more than I would like. But, you know, oh, some of that is this. That number of lines will go up over time because we do use some assembly instructions. So as you support more CPUs, it has to get bigger, which is unfortunate. Also, we have some OS support in here. So as you support more OSs, it has to get bigger. But at least it's things that don't compile on your OS, right? So it's not that much in terms of overhead, just in file size. Okay, but the point being, we have this system entry point function that does some stuff. And actually, these we don't even use right now. They're just empty. I mean, the point of these is you have a place to insert code, but like I don't think we even do that yet. But we'll probably leave those. But we call this runtime init here. And this is like literally all that we do on startup. We don't do a ton of magic things like every other programming language. Part of it is set up temporary storage. So this is where, when we give you a default allocator that's not C malloc, this is where we would set it up. And it's just, because this loads for every meta program and every user program, it's just I want to keep it minimal, right? So that's the concern. Okay, this has been way too long of an answer on something a lot of people don't care about. Okay, bit fields. Are bit fields on the roadmap? Kind of. Again, there's a little bit of a tactical thing here, which is what I wanted from the start of the language was to be able to do something like this. Just say S is some struct, and you say foo is true and bar is false. Like, these are Booleans, right? And then you can write a program that uses these, right? Whatever. Ideally, at some point, if you had a bit field type, you could come along and just say bit field, I don't know, let's put a hash here. It doesn't make any sense. This syntax is not real, right? Foo, right, bar, I don't know, right? And it would compile the same way. Like all your code would still work. And this is great because you could be lazy and just use full Booleans for things and then change them to a bit field. Now, bit fields have consequences in terms of multiprocessor programming, right? You can't actually influence an individual bit from a specific core. And so the reason, there's just a reason as a programmer to be aware of this, because you can't atomically change bits. That's just not a thing, right? And if you're writing the kind of code that wants to use bit fields, you're writing low-level code that's trying to be efficient. And well, as of 5 years ago, being efficient means trying to use multiple cores efficiently. So these two things, it's like maybe bit fields just aren't that good of an idea anyway, because you're trying to sweep under the rug where things are stored, and you actually care about that. So that's another reason not to use bit fields. So the reason I've been a little slow to just jump up and implement something like this is we already have this feature called, enum flags, where we auto increment the flags every time and whatever. And so we already sort of if you have that, then we've got this flags where we have individual bits. It's just that and then if you put this, right, you have foo and bar referenceable on S. It's just that the meaning of this is slightly different than what you want as the bit field. Like if you say foo here, you're actually talking about the constant value of flags.foo. So if you type this, you could actually say s.foo, and that's even a constant, and that works. But you can't say s.foo equals true, because this s.foo actually refers to the actual numeric flag value. And so that's a little bit like, do we just allow this to work? That's a little gross, but we could do it. But actually, the more complicated and confusing thing is we also would then want s.foo to not mean the constant value of the flag, but like whether it's set or not, which is a different thing. And so it's just like it needs a sitting down and thinking through of what is really the best way to do both of these things. But like I said, maybe bit fields are just a frickin' bad idea anyway. I kind of think they are. Like the fact that you still have to C style manually or bits in. Well, I say C has bit fields too, but people don't use them that often. The fact that you have to manually or the bits reminds you that it's a whole word occupying certain memory, which if you're a low-level programmer, you care about. And so maybe it's not a good thing to hide, right? That's the thought process that goes through my head when I think about this. Language uses special macros to interact. Wow, we're obviously going to have to do another Q&A. So my hard stop for this is 4 p.m. Eastern, which will have been long enough because it'll have been 3 hours, plus also that's just long. 3 hours is long. Let me turn up the heat in here for 1 second. Because I live in a modern apartment building, just like my last modern apartment building that I lived in across the country, we have decided it's impossible to actually control the heat in your house at a reasonable level. You have to go turn it up and down all the time. Why? I don't know. Okay, the language uses special macros to interact with for loops via for expansions. Is any other place we can interface with language constructs via macros? Not specifically. Like, I don't want too much syntactic magic like that. For for loops specifically, I felt like it was probably worth it because it's so common to do them. And what I wanted was a way to implement iteration for data types without doing all the banana cake C++ stuff, right? And some other languages do slightly better versions of that. So like D, for example, cleans up C++ iterators a little bit, if I remember correctly, and so do other languages since then. But even if it's a little cleaner, you just still end up with all this code to write iterators, and that code doesn't look like, I think I did a whole stream on this that might still be on YouTube. That code ends up being a lot more code than if you just wrote the loop by hand, and it's harder to understand. And it just doesn't look like writing the loop by hand, which all seems wrong to me. And so that was the goal, was to come up with a way that you just write the loop by hand. So now that is a special case syntactic magic in the programming language. And it's really more complicated than I would like. Like, before thinking about adding more syntactic magics, I would try to think about how to generalize this one more. So for example, you write your for expansion, and then, you know, there's ways of replacing the loop controls in the insert directive, right? So the insert directive has parameters for break, remove, and continue. And why? Because that's just what we needed. Could that be generalized? Probably. Like, part of the reason I did it that way, of putting that stuff on the insert directive, is that it dovetails with this idea we discussed already about having these Lisp style macros that modify code and return new code, right? And you can already do that. I think it's still a little bit too verbose for people to want to do all the time. And so that's part of the problem that we're solving currently, is like, just how do we make these macros nicer to use and just easy to think about, which is part of nicer to use, really. And so part of that is maybe user support in the modules. I don't know. But yeah, I'm not like, I would like to simplify the for expansion stuff. And then maybe in the process of that, we'll see more ways to apply it. Like, I wouldn't be against that, but I'm not just chomping at the bit to be like, how do we add more syntactic exceptions to the language? Like, that's not what I'm thinking. Okay. I'm going to skip replies to other people's things because I don't want to spend time reading through those, so we can crank ahead. Okay, question. What is the official stance on temp allocator being moved to the context? Maybe somebody would rather have a large ring buffer instead of an arena. For a program that doesn't have an obvious reset point. It is in the context. Okay, so I think what you're really saying is you want to substitute a different temporary allocator in. I see what you're saying. Okay. So let's actually, this is in preload. So preload is some more lines of code, but why is Emacs not working correctly? Like, just draw the text of the file name. It's not hard. Okay. So preload has data structure declarations, basically, and no real runtime code. So here's the temporary storage. This is some data structure that's defined here. This is what you get by default, right? Okay. And then in the context, right, we have a pointer to it here. Now, the fact that there's a pointer to it here means it's pretty easy to swap pointers if you want the same kind of a thing, right? If you want a different facility for temporary storage, you can, of course, add it to the context. But then, I think this is the question, if I understand. Then the problem is the functions in BASIC that operate on temporary storage don't operate on your temporary storage, right? So they, you know, because the thing is, okay. And the other thing is that temporary allocator, like when you set the allocator to the temporary allocator, which is how you use this a lot of the time. Is that in here or is that's in runtime support? Where is it? I don't even know where it is, guys. Maybe that's in basic. Oh, it's in basic. It's right. Because I want as little stuff in here as possible, it's in basic. Right? Temporary allocator. Yeah. So all this stuff is here. So this is all swappable, right? The problem is if people are using basic, they might use this explicitly. And so they don't use yours, right? And so I think the question is, can all this stuff always be on an indirection the way the regular heap allocator is, so that people don't call this directly? And I'll just explain the reason I didn't do this originally. This may or may not be a good reason, but it's the explanation, right? And the explanation is that I just didn't want a lot of overhead on temporary allocations because you maybe do a lot of them quickly, right? So I didn't want a lot of indirection. I didn't want, you know, I wanted this to be a very cheap facility that is still maybe not as fast as Alloc, but very close, right? And well, okay, so I'm showing this temporary allocator proc that has branches in it and stuff, but this is how you pass things to people. That's I don't know why we're calling this here. This should not do this, honestly. This should go the other way around, where if you call this, I don't know why this got factored this way. If you call this, because this is the general routine that's a little slower, and you get allocate, it should call temporary alloc, which should have this in there. So that's going to go, I'm going to write down to refactor that. But the point being that you should be able to inline this, and it's very simple and straightforward and doesn't do a lot. Although looking at this amount of code, this is more than I wish that it was. Maybe we can streamline this. This is here, you know, to just deal with like overflow pages and stuff. But, okay, back in the original design of the temporary allocator, we didn't have overflow pages. Or we had a simpler thing where if you overflow, we would just call a slower allocator and leak the memory. And I just decided that wasn't the way. So anyway, the original decision was made to make it be as fast as possible. Because, you know, if you call a function through an indirection that you don't know where it is, like that's just kind of slow on a modern CPU. Like, you know, how slow it is depends, but it's kind of slow. You don't want that in a tight loop. And so we're just trying to make it be something that's feasible in a tight loop. And maybe with this amount of code here, with this number of branches, although these are mostly easily predictable branches. So maybe it's fine. Again, I don't like the way this is factored and would change it. I'm going to change it as soon as the stream is over. Oh, you totally did make NPM. Okay, I just haven't been paying enough attention to that stuff then. So use Ian's NPM. Or complain to him about it if it's not good enough. Okay. That was a comment from an hour ago. I'm trying to get through this girl back, everybody. I'm trying my hardest. Are there plans to remove some modules that come with the compiler? Yeah, I think I mentioned that. But yes, I would like to move at least some of the modules out to user level, for sure. That said, I could envision there being a category of stuff that's like, we don't want to be in charge of maintaining it because we want to focus on the compiler itself. But there's probably some set of things where it's like, look, it's just useful to distribute this with the compiler. So maybe we pull it down from, maybe it's user maintained, but we checkpoint it into the compiler distribution once in a while. But you could get a newer one if you want. Maybe that's a thing, I don't know. Okay. Is there a case for adding simple immutable pointers? Well, we already have that. Sort of. Right? When you pass a struct, for example, to a function, like that's a const reference, which is a pointer. Like all the stuff that C++ did to confuse people about references and pointers really wasn't very good. Now, that's again just not the same as having that generally in all cases. Yeah, and I don't know, it's another one of these things where I just haven't found myself wanting or needing it that much. Because the thing about const pointers in C, they're not real, like you can cast them away at any point. So they don't really give you any guarantees, right? So languages like Rust at least try to do better in that department and are more serious about things being immutable. Do we want to be more serious about things being immutable? Well, the thing is, the reason Rust can do that is they buy into this whole analysis framework that doesn't let you violate those constraints. And the style of language that this is, we would have to let you violate those constraints at some point. And so maybe we even discourage it, right? But it's hard to envision a version of a const pointer that isn't still at some level the C-style milquetoast const pointer. Is that useful or not? Maybe, though. Maybe. I know people claim that const pointers help with optimization a lot. How much is that peculiar to the semantics of C? Because, you know, like I said here, if you pass a struct by value, it is a const reference. And so the optimizer just knows that, right? And so it just remains to be seen. I haven't wanted to add more pointer types because it just complicates the type system It gives you more things to think about and deal with. When I program in C++, all the time I get annoyed by const pointers. So I don't know. Basically, I haven't had a super strong motivation for adding it, but I could see there being one in the future. In general, let me step back 1 second. In general, to the question, are you going to add X, or is it a good idea to add X? I think the answer to that kind of thing broadly is maybe. However, it's always better to move laterally than to add more things, all else being equal, right? Like, we're at the point where this language is kind of complicated now. It's not nearly as complicated as C++, right? But it's a little complicated. And so we just want to manage that complexity. And so adding more things has a cost that is greater than you think, right? It's an opportunity cost in terms of implementing other things in the compiler, but it's also greater than you think because it pushes like the friction imposed by complexity is super linear. It grows faster than n, where n is the amount of complexity. And so just the more you add, the slower it becomes to do anything. And we're already well into that territory where it's a lot slower to do things than it was in the beginning. And so I'm just very careful about this stuff, right? I want to keep us from, right now, there's only 2 people working on the core compiler, and one of them not full-time. Actually, both of them not full-time. It would be nice to grow that, but nevertheless, you very quickly, if you're not careful, can end up in the territory where you need a team of 12 people to do anything, and even those 12 people don't get much done. And I don't have money to pay a team of 12 people to do this, so there's that as well. Maybe someday, not today. So that's just the thought process behind all of these questions of like, will you add X, will you add Y? It's always balancing how well does this fit into what we have, or how well can we laterally move what we have to fit this thing, times how good is the benefit, divided by or minus or something, how bad is the damage. And that's the main part of my job when I think about where we should go, is weighing this cost-benefit analysis, and it's actually very difficult. Doing a good cost-benefit analysis is hard. But I tend to err on basically every other programming language in history has failed to do this. At least all the popular ones have failed to do this cost-benefit analysis correctly, and they end up being way too complicated with way too much stuff. And so trying to err on the side of not doing that is the general aesthetic that I go by. How to prevent environment community from being poisoned by bad ideas once the language is used more broadly. I don't think it's possible, right? Here's the thing. We're living in this environment where the educational system mostly teaches people bad ideas about how to program. And then once you graduate from school, it takes a long time to figure out which of those ideas are bad and which ones are good. And most people never totally get there, probably including me. So like, people are going to wreck stuff. Like, once this is released publicly, someone's going to turn it into whatever bad programming language already exists. That's just what people do, is they like, especially programmers, is they want all the things from what they already have, even if those are bad. However, what can be done is to keep things modular. So one of the reasons I'm not releasing this publicly, because people ask me why all the time, and it's I want to get it as far as possible with a chef style design so that the example is at least set, right? I want the existence proof. You can have a language, it's this many lines of code. The runtime library, right, this equivalent of libc, is pretty small and it does a lot for how small it is. And I want that example to exist clearly at some point in time. And then you release it to everybody, and then just shit burgers get thrown everywhere. And I expect things, I would appreciate it if people keep things from degrading, but I expect it won't go perfectly, right? But at least people who want the smaller, cleaner version will have that option. And maybe that could even be the majority. If we do a strong job of setting culture and trying to propagate forward the understanding of why it's not a good idea to overcomplexify things all the time, right? But here's the thing. Programmers that requires discipline to not overcomplexify things all the time. And it's hard. Like when I work on the compiler or I work on the game, all the time there are things where at the time when I first implemented them, I was confused about how it really should be, or it just seemed really hard to do a good job. So I did something suboptimal. And, you know, do you have the discipline to go back and rewrite that or not? And are you content enough in your life and your practice as a programmer? Like, I think one of the reasons why so much code is bad is people have this existential angst all the time that, like, their life is draining away before their eyes and they're sitting in front of a computer and it takes them so long just to do anything and debug all this stuff that once they've got anything that kind of works, they don't want to go back and spend more of their life doing it because they know they're going to die alone, right? That's basically what is determining modern software. There's something beeping in my building. I hope it's not a fire alarm. There's some probability I will have to evacuate. Maybe that's just a really loud truck outside. We're on the 6th floor, but yeah, it sounds like maybe it's a truck outside. Anyway, the point being, yeah, I will do, like, I still don't know when we're going to release this publicly. I don't know what the conditions will be. I will try my best to steer culture up until that point and even after that point, but you just can't control culture, and you don't want to. You want to let people innovate culturally. The problem is most of that innovation will be bad because that's the nature of innovation. So we'll see. Maybe that people in chat would like a bigger Emacs font size. Oh, well, I saw that just now. What do I think of the idea of having a following statement parameter that captures the next block or statement as code? Okay, so you're talking about a way to do the Lambda style thing. Like some languages, you know, when you have a Lambda, you can like write a block afterward, and it gets passed as the body of the Lambda. In fact, I think C++ might even do that now. We don't do that. So I agree that that's nicer to read. What I would say about it is we may do that eventually, but I still think there are enough foundational questions in terms of how code works, how macros work. And then also, you know, we still might do lambdas like with closures, right? With capture. Right now, there's no capture. I don't need it usually, but we might do it. And so you would want this to work for both. And so I just think it's a thing that we do later. I think it's a thing where for now, you just don't do that. It's just syntactic. It's fine. And later, if we do it, we do it. But I would like to do it with the mindset of having made good decisions about these other things, about the core. Is there a setting for minimum compiler version? There isn't currently. The problem... There's sort of two fundamental ways of doing that. One is it's just a directive that you declare. And that's sort of a hard-coded hack way of doing that. But the good thing... Well, I don't know. Either way, so the problem with declaring minimum compiler version is, or using minimum compiler version, is just if somebody has an older compiler, it may not be able to parse your program completely or whatever. And then you can't even get to the point where you make enough sense out of the program to enact the functionality about minimum compiler version, right? That said, maybe once syntax is mostly stabilized, if it's a directive in your program, the hard-coded hacky version, then at least we don't have to type check your program in order to see it. And so we're not subject to type checking incompatibilities, only syntax incompatibilities. I mean, I can see the usefulness of such a thing. I think it's not obvious what's the best way to do it, and so we should probably just talk about it, think about it. Would it make sense to limit the scope of variable introduced inside a macro to the if statement if the macro is called inside the ifs condition? That's a weird question in the following way. It's sort of as directly asked, it would be a scope hack that's kind of weird and inconsistent. However, we don't currently let you do a declaration inside the condition of an if, but I could see doing that, right? I could see allowing the following thing. Like we don't let you do that. If we did that, what would the scope of this be? I think the only clean answer is there's essentially another scope that you don't write that's like that, right? And then if that were how that went, then that's where the macro insertion would go, and that would make sense because you can see it from the body, you can see it from here, you can't see it from up here. Oh, we went back to small font size. Now, again, though, the reason I'm not chomping at the bit to do this is, again, this sucks for debugging anyway. Like, really, it's kind of just better to do this, right? The reason it's not better to do that is that it pollutes your parent scope if you didn't want that variable in your parent scope, right? That's the only reason. It feels cool. I understand the way in which it feels sleek and cool to write this, but like, it's not good in the debugger, and it's not... Now, that said, maybe that's a problem with debuggers, and if debuggers ever improved at all, this would be better, but debuggers haven't improved in like decades, so don't get your hopes up, right? Anyway, so now the thing is, to be consistent, we might want to allow this. I did recently allow this for while loops as a way of naming the iterator so that you could break from the iterator. And so, and maybe that particular thing is a little too much of a silly hack, but you know, that way you could say break X if you're, because before this, we didn't have a way to do that, right? But this could also be done if we end up with goto labels, because we implement goto. Instead of doing this, this could just be, I don't know, whatever your goto label is. I don't know. The colon is already sort of looks like for loop syntax for something else, so that wouldn't be the right thing, but yeah. Being able to put notes on stuff other than structs or struct members would be a decent enough stopgap measure. Yeah, it's just the problem with that is that where exactly do notes go and how do you deal with that? Like if you could put notes literally anywhere, like, right, on any expression, now any meta program looking at your program has to like see notes flying at it through the hierarchy all the time, which is annoying. Or notes have to be stored on the side somewhere, which I think I would prefer. That actually might take less memory too. If you had notes on the side, just saying, here's the notes and here's the things that they're on, but then you have to like match them up in some way when you care about notes. And so I do think the places you can put notes right now are a little bit restrictive. It would be nice to put them anywhere. It also could be error prone though. What if you put one in slightly the wrong place? Like the fact that it's limited where you can put them right now means that we have error checking also on what you meant to do. So these are just things to think about. I'm skipping through discussion. Are there plans to extend if hash complete to support fixed size constant arrays? Fixed size constant arrays with elements known at compile time. So it would be, you want this in tag union, which is distributed with the compiler, so you could handle every entry in the value types vargs. I see. I just hadn't thought about that at all. That had never crossed my mind. We could think about it. I think to justify it, we probably want more than one use case like that, because that use case, you could check with a meta program, right? You could just look at the cases and make sure every case of the array is covered. That's a little bit more heavyweight than if it were a built-in compiler directive like that. But heavyweight things for things that don't happen too often, I'm kind of fine with. You would need some way to indicate, either way, whether it's built into the compiler or a user level thing, you would need some way to indicate what are the things, like what is the array that declares the values, right? You know, broadly speaking, I feel like we are at a time where for this kind of thing, I should lean much more heavily toward having it be implemented at user level. And if that is inconvenient or annoying, work on that problem, right? How do we make it less inconvenient and annoying to do these things at user level with certain caveats, right? Because one of the things people are going to want is like totally arbitrary syntax or whatever. We're not doing that. Not only because it causes, you know, problems and slowdowns in parsing and all that, but it was bad for Common Lisp. Like in the Lisp world, people made all these domain-specific languages because you could do that with the macros. It's like, oh, here's my other language that like also is flat syntax like Lisp, but it has totally different meanings for everything. And like, that's part of what killed Lisp is like all these programs written by the enthusiasts were ununderstandable to anyone else. And so I would like to keep the syntax, I would like to keep the syntax fixed, but that doesn't mean that it can't be fixed in such a way that it's more convenient to write certain classes of things or whatever. And again, that's what we could talk about. But I do think yeah, I do think for that kind of a thing, I would like to explore how do we let users do this, right? Because at some point, let's just stop adding stuff into the compiler, right? Also, if you let users do it, you're opening up Okay, on the one hand, you're opening up this field of experimentation where more people could try more things. On the other hand, you maybe end up with the Linux distro problem, which is why Linux is stuck in 1997, right? I don't know. If people don't know what I'm talking about, since we have a lot of viewers, I'm talking about this. My favorite graph on Wikipedia. Wikipedia is not for sale, by the way. Okay, here we go. This is all the Linux distributions, and so the thing is, Linux today is still more or less the desktop workstation that I had in 1990 in college before Linux existed. So all this work didn't really push things forward is the problem that I'm talking about. And this is just like, this is why, again, when people ask, why haven't I open sourced the thing? It's like, well, because this is what happens is just think of the enormous amount of effort here, right? There's just like photons bouncing around randomly. If you could have focused all this into a laser to like be deliberate and get deliberate things done, you would have a much better operating system than what we have, right? But you can't somehow. And now, of course, when you try to focus things into a laser, you get a lot of people who don't like that color of light in the laser and they don't want to participate. But I still think the overall effect would be much better than this. This is just a fucking complete disaster, right? Like, what the actual F is going on here? All right. I'm sure this isn't even like, do you see how there's not that many lines on the right? I think people just gave up adding things onto this graph. Because, like, there's way more. Like, where's Mint? Linux Mint. Linux Mint is listed here as one distro. It's like 6 distros by itself. Anyway. I don't know, guys. Okay. Yeah, that's not even close to complete. I think they just gave up on making the graph. Re-bit fields, you meant that mostly for binary protocols defined externally. Yeah. That is one advantage. So, you know, I mean, you can use enum flags to translate the bit field, sort of. But you would end up saying like bit 0 of this, bit 1 of this, bit 2 of this, bit 0 of this. I don't know. It's worth thinking about for that reason and for porting things. When I write my own new code that wants to do that kind of stuff, I just shift and mask, you know. So I think it's a thing that a conversation could be had about, though. When converting C files over direct one-to-one struct representation, the biggest pain is not having the facility to make variables smaller than a byte. Is there really that much C code that uses bit fields? Because I never encountered that much, but maybe people do it more now. I don't know. Speaking of simplicity and stuff, simp module starts with a comment stating its purpose is to see how simple rendering module can be while still being usable. Am I generally satisfied with how it's turning out? Same question for GetRect. Yeah, I mean, here's the thing. let me tie this. I'll go back to the more general question and tie it back to more specific things. Let's just so we have an illustration, we'll go to the simp module. In general, there's a question about the code that comes with the compiler. What should it be? Like, okay, actually, let's let's go to the hash table. Hash table is a module that a lot of people might want to use, right? It also has a big impact on the performance of programs. So you might want to rat hole in one of two ways. A, you might want to try to make a hash table that has a ton of tweaks for all sorts of different cases that people might have to try to optimize in all those cases. Now, it turns out, I don't think that's really a good way to go because those cases cost things and hash tables have to be so fast. Like the hash table in here is tuned to like hit most things on the first hit, right? And be pretty fast about it. And so, well, that's a specific use case, but this use case makes more sense when you have a bunch of things that you're querying frequently so the hash table is in cache, right? If your hash table is out of cache, you might try to minimize the amount of space it uses, or I don't know. Anyway, it's hard to be much more minimal either. So like, so I designed this one. I iterated on a design, but this one came from, I think, Charles Bloom originally. I mean, I've got quotes from Charles, but he might have been working with other people at RAD, like maybe Fabian or Sean or whatever. Oh, and also, yeah, I started with some code from Sean. This has evolved very far since then. But the point being, actually, I think for hash tables, for them to be good, they have to be so minimal that they can't be like the heavyweight Uber table. But you could imagine that, right? A different philosophy that you could have, and I think C++ does both of these. It both tries to do the Uber table, but it also, well, it tries to do the Uber table, but that's implementation defined, probably, right? But it also tries to do, here's 27 million data structures for different things. And because they're trying to cover every use case for everybody, and I sort of feel like we shouldn't do that because, again, the costs of these things are higher than everybody thinks, right? I think there's a great degree of value in having the code underlying the system that you use to be so simple that you don't mind going and looking at it. Like, dude, even in the 90s, when I would go back and try to step into libc or whatever, it's a freaking nightmare. And I'm like, I'm suddenly in this super ugly realm, 10,000 leagues under Hades, where everything sucks, right? And it shouldn't be like that. Because that's a barrier to understanding. It's a barrier to enjoying, right? And so I want to keep the code that we distribute with the compiler very good, performance-wise and cleanliness-wise, but also simple and understandable. And I'm going to place more weight on simple and understandable than people historically seem to have in most cases. So, you know, this hash table, like I've said on stream before, it's 472 lines. The code doesn't even start until line 100. So it's 372 lines. And there's a bunch of comments, right? Like, it's not very much code for a core data structure that we use all the time, right? The array operations are similar. It's a small number of lines of code for a large amount of functionality. So that is the philosophy generally. Now, when we come to higher level things or things further from the core like simp, which we could run the simp example to show people what it does. Why am I not getting autocomplete? I must have a lot of files called module. So this is just a test program. it does a simple, let's draw a square and some text and a bitmap and handling events, right? I think there's some key presses I could do. Maybe we don't handle events in this one. Maybe it's a different demo. But the point being to do this kind of thing as simply as possible, because as soon as you have this much, there's a lot of programs you can write. And I still would like this to be as simple as possible, but I think for this kind of a thing, it makes a little bit more sense to lean toward functionality a little bit more, simply because it's less core, right? At the same time, though, the disease that we're constantly fighting is that every year there's more and more source code, and it does the same amount of stuff or less than it used to in the past. And so I'm very conscious of that all the time. Am I happy with how this is going? I am. What I would like to do is figure out, there's a small number of shaders for this. The way we keep it simp is by having a very small number of shaders and you use them discretely. What that means is you can't be super specific about how you shade a polygon, right? What I would like to do is a metaprogramming thing where we just translate a function that you write in the regular programming language into whatever the backend shader language is. And that would understand just some set of primitives like sine, cosine, whatever. Saturate, it would understand some set of things. And then you could just write the functions and it would remap them. And you could also test them in regular programming and not just the shader. Is that a good idea? I don't know. Maybe it'll suck because the number of primitives you have to support is very large. But that would introduce a large amount of flexibility for hopefully not too much extra complication. Certainly not that much extra interface complication, right? So the challenge that we have is, because we're stupid and decided that the model of programming that existed for decades and served us very well, which is that you have one language that targets multiple systems, we decided that we're not going to do it that way when it comes to GPUs because GPUs are different. So now you have different programming languages even for the same GPU, depending on your operating system or whatever, which is complete banana cakes. It's horrible. We're spending all this time dealing with problems we shouldn't have. It's so bad. And people can't imagine anything different because programmers know what they know. But so the way we deal with that in simp is by completely walling it off. Like, we do not talk to the graphics API in any way. And because the graphics API is so wide in terms of the concepts you deal with, we try to minimize the number of concepts you deal with. And that's why the so-called shaders that you invoke are very explicit, because that's just the way to make it simple that I know how to do. Otherwise, you end up dealing with driver APIs very quickly, right? Like, if you try to use SDL and you use OpenGL to draw, you're using SDL GL now, and you're doing a lot of GL stuff. I do not want that. So it's very simple to use. As long as you don't want to go beyond a certain point, you have a lot of functionality. But, figuring out how to give you a little more functionality is a bit more. So now getRect, which we could run that example. This is a widget set. So the default thing here is, it's a little bit ugly, but you can see that we provide all these things. And the idea behind this is it's supposed to be user expandable, where you add your own widgets and all that. I'm pretty happy with how it is right now, just as a non-expandable thing. The question is, how well do we do the user expandability where you add your own widgets and stuff? And I suspect that's not quite there, but I don't know. We just kind of have to try it out. getRect is a little bit earlier, I think, because, see that? We didn't correctly mask this click. So the button is seeing the click even though it's on a foreground window. Anyway, There's little things like that to worry about. But I'm pretty happy with where they are. They're just at different phases because they're different levels of complexity. Okay, we got a half an hour left. Sending this because I'm talking about loop breaking and goto. 99% of the time you want goto, you really just want the ability to break a block. Right, that's another thing that we could add. Like there are just different ways that you could think about implementing this, right? The question is, in that 1% of the other time, do you really, really want goto and we have to implement it anyway? Like if we're going to have to implement it anyway, even if it's cleaner to break a block, we might as well implement goto first. I don't know. Any plans to what comes next, milestones for next year? Not really. I'm sort of winging it right now. The compiler, the very next thing is the compiler just got slower recently. You can see it takes almost 2 seconds to compile the Sokoban game now. Although that might be old. No, that's as of last night, actually. I found a bug in the compiler that was adding 100 milliseconds. And that's actually, you have the fix for that. That went out in the beta last night. But this is still way too long. Like in mid 2021, this was like 0.07 seconds. And so I don't know WTF happened. So we have to look at that. Link time and stuff we can't do that much about. But I don't know why this got so much slower. Although I got this from 1.5 to 1.4 in like a couple hours. So there might be multiple issues like that clouding it up. We'll see. Or maybe something is happening. It's always possible that there's something about the design of the language that is having problems as things get bigger. There's two levels of that. There's like stuff that's just like, oh, this data structure you're using for this thing is not going well when things get big. Or there's a fundamental design issue. I don't think it's the latter, but you never know. And so I want to look at that a little bit because the compiler's too slow right now. And some of this slowdown happened dramatically recently. Like we went from 1 second to 1.4 seconds in like a couple months. I don't know when it happened. So something's got to get fixed. But in terms of features, I don't know. Like I think we covered a lot of them. I want to make macros better and cleaner, and I want to make it more possible to do things at user level and attack some of these bugs that are coming in, some of which make me question at least core design decisions, right? Oh, and also getting rid of the necessity to have libc on the back end should happen, over the next month or something. Yeah. You think I made it bigger and forgot? Oh, I didn't. I just felt like we're not using that much of the text. If we're using it more. Oh, it was covering the simp demo and stuff. Sorry, guys. Anyway, we make it smaller. Okay. It would be nice if simp can draw lines. No, the way people in the real world draw lines is they draw a rectangle. That's just how you do it because you want to control line thickness. And as soon as you control line thickness, you're talking about a rectangle. Like nobody draws lines anymore. Curious about what the language could do to make parallel code easier to write and reason about. I didn't skip that question deliberately. If I missed any questions, we can try to hit them here at the end. The answer is I don't know how to make parallel code easier to write and reason about, apart from the metaprogramming things that we have done, right? So the metaprogramming system that we have allows you to do a lot of things that you cannot easily do in other languages with high confidence, like say, this global variable is only readable from certain files, or this file is only allowed to do a certain class of things. That helps you a lot with parallel programming in ways that you are not helped in C++ or whatever. Now, again, I'm going to give a very short version of this rant, but I'm sure someone can point you at a longer version. Lots of programming languages these days have ways that they claim to help you with multi-threading, let's say. The thing is, none of these ways make sense to me as somebody looking at high performance systems programs, because they all involve things that are not really what you want to do, right? So all these systems about we have a bunch of fake threads and they're mostly software and some of them are hardware, right? That's like using a garbage collector to manage memory, right? Except worse, because threads are directly impacting your performance, right? There's all this, we very much restrict what you can do, and you copy data into a thread and copy data out, and that's how we avoid, or data is immutable as long as, somebody holds a reference to it from another thing. Like, all of that prevents you from architecting the kind of system that you really need to architect. It is very, very, very hard to get even kind of some of the performance available from a multiprocessor system. Most programs that you use just don't get most of that performance, right? If computers are ever going to get any faster than they are today, we have to figure that out. And it's really hard. And what you find, even if you don't use any abstractions and you're very meticulous and you're very low level and serious about trying to orchestrate different threads working together, what you find is it's very easy for like log jams to happen, where one thread took a little too long on a thing and then somebody else was waiting for that guy and somebody else was waiting for that guy. And then your whole system just starts becoming a lot more serial, like Al Gore. So you have to avoid that. And the way you avoid that is by having things not wait for each other as much as possible. And that's really hard. And it's a different kind of thinking from serial programming. So this whole thing about like, I've got a serial program and then we just go kind of do some stuff and then we've got a promise or whatever. Well, I don't know. Let's not bring promises up because I think they're kind of irrelevant to anything. But just that whole idea, like the kind of architectural thinking that works there does not get you to a fast multi-threaded system. And the problem that I have, so working on the compiler, the problem that I have is it's hard even to get to a reasonably fast kind of single-threaded system. We haven't even got there yet. Like, it takes frickin' 1.4 seconds for us to type check the Sokoban game right now. And that's way too much. So until we get that down, what is even the point of being multi-threaded? And I don't know, it's just hard, right? And so when I think about this as a programmer, what I would like is something that helps me with this hard problem. And, most of these features that people design into their languages to supposedly help you with threading helps you with easy problems and doesn't help you that much with hard problems. So like hard problems are not putting things in another thread. You can do that. But like, how do you actually get the performance out of putting that thing in another thread? And if you're easily satisfied with a little bit of performance, then it's fine. But if you actually are a performance programmer, you'll see very quickly that you're leaving most of the performance on the table with those kind of systems. And so it's hard. I don't know. So that said, most of the things on the internet that you see about people being happy with this stuff are people who have embarrassingly parallel problems. That is, you can look that up on Wikipedia, right? Problems that naturally can be divided easily into independent subproblems between which there aren't data dependencies. So you can do those. And those kind of problems are not that hard to kind of mostly get performance on. But most other problems are not embarrassingly parallel. And those are the ones that we need to go faster if we want computers to really be faster in the future, right? And so it's hard. And I'm thinking about it, but I don't have good answers to what would be good features apart from improved but yet versatile error checking. Are there any plans to debug your own compile times? I would like to do something like that. The question is, how much overhead does it add to the compiler and thus slow down the compiler, right? And would we end up distributing a different binary of the compiler, which again is something I'd prefer not to get into, but eventually maybe would. Skip the question about how libraries should understand communicate freeing resources. That I don't understand the problem. Like that's just the same as in any programming language. I don't get it. Could we put the slideshow program in the examples? The reason I don't do that is just because it's not that WYSIWYG right now. But if you wanted, I could put it in there, I guess. I was at some point going to use GetRec to make more of an interface for it, but that does not exist. Would it be possible to distribute beta access only compiler update videos that go more into depth into feature changes and ideas? Maybe. So some people like watching videos for technical information and some people don't, because you can't really skim a video very effectively, right? So if you don't want to spend a lot of time getting the answer to something, actually text is better. So I don't know. I think that's a category where different people have different opinions about what they would like. So hard to say. Doing those videos also takes time and energy for me, depending on how much like a presentation they are. But if they're just like this, if they're me chilling and communicating information in a way that doesn't require prep, then maybe. But you know, you'll see a lot of the updates lately have been bug fixes and stability, which doesn't really require that kind of thing. We did add some features in the newest beta that could use an explanation like that, but I felt like the how-to was good enough. I don't know. We'll see. How does bytes work? Bytes literally says, put these bytes into my machine code. Are there any examples? I don't know. I don't know. No, that's showing it. Yeah, probably literally nobody uses it right now. The reason we added it was it's sort of more for forward compatibility. Like what happens if you want to insert machine instructions? Well, basically, okay, what it enables is you could write your own assembler, basically, right? You could write your own assembler that computes a byte stream and then use bytes to just insert that as machine code. Like I felt like that was important to allow people to do. The other reason we did it was just because at the time there were some instructions we didn't support, but I think we support them now, so we took it back out, the use of it. Problem is most tutorials are long. Most things can be explained in 2 or 3 minutes. Yeah, but that requires more prep on my part. And I'd rather spend the time improving the compiler. Will I let users view key parts of the compiler source so that they can understand the internal functionality? I mean, eventually we will release the source. In the interim period, I don't know. Like I've already had very bad experiences regarding the source, which I will not elaborate on, but like I've already been burned by people being skeezy. So Like, I'm just not. And also, again, the reason why I don't do that many videos is because I feel very abused and mistreated by people who take the content of those videos now and use them to, again, be, they may not think of it as skeezy, but I think of it as super skeezy. So I don't want to reveal that kind of inside information anymore, because people are using it to try to harm this project, right? So why should I give people ammunition to shoot at my project? I shouldn't. So that's just why we don't release internals and stuff. Eventually it'll be open source. But in the meantime, no. Why is count in arrays S64 instead of U64? Is there a use case for negative counts? There is no use case for negative counts, but if you make a lot of things unsigned, then you end up having a lot of casts, or you end up being surprised because you tried to subtract 2 and you got a negative number, but it wasn't negative, right? Like, unsigned ints carry a little bit of surprises with them, so we just default to not using them so that you don't have to think about it, right? And also, you just don't need that high bit. You don't need bit 64 in your array count, so it's fine. What's the status on ARM compilation? I mean, we did an ARM executable a long time ago. Ignacio did it. He output a switch binary. And that's done just by telling LLVM what to do. And I believe that's still possible. If it isn't, we'll fix it. I don't think we have anyone actively doing that in the beta, but I would like to have someone actively doing that. Now, since then, since we added x86 assembly, there's an added like small speed bump, which is that you have to not use functions that use x86 assembly or comment them out or rewrite them. But that's just a temporary thing, because what we need to do in all those cases is put a static if around that and say, if we're on x86, do this, otherwise do this fallback implementation. And there will be some cases in which there is no fallback implementation and we static assert, such as, for example, compare and swap. Like, if I don't know your CPU, I don't know how to compare and swap, right? Maybe we could add an intrinsic just for that, for simple 8-byte compare and swap. And that could be a thing that at least LLVM could handle. Because the only reason I say that is because runtime support uses that to start up. Like, literally, you can't even start a program on ARM without replacing this right now. So having an intrinsic here, it's just we don't want intrinsics for most things. But having one here that we pass to LLVM might give us that flexibility. Have I settled on a license? No. We probably make our own. Oh yeah, okay. Right. So there's 3DS and Playdate compilation going on. So we'll solve these problems as we go. And yeah, I would like it if we were actively running ARM executables over time, right? Okay, we got 10 minutes. Final questions. Thanks to everybody for coming by. We have way more people in the stream than are in the beta, so that's cool. I hope this has been useful and interesting. We'll do another one soon. I don't know, maybe next year. Next year sounds so far away. Yeah, it is not that far away. I could say see you next year and it would be less of a break than my usual streaming breaks. Are there any other questions that I missed? I think what happened was there were, I was really behind. I was like an hour behind at one point, and there was a bunch of things that looked like just discussion back and forth, so I scrolled past it. And maybe I scrolled past questions in that. So downward inference works in some cases, not others. It works for struct array literals, but not binary ORing. Yeah, I mean, that's sort of a special case of downward inference. And I guess when we talk about binary operators and stuff, it's just an extended version of that. Is there a particular compiler internal reason why the former is easier than the latter? So inside an array literal, for example, you can only have constant values, right? And those constant values can only be of the array element type, or, well, that's literally all they can be. They have to be one thing, right? So you can't, in an array literal, arbitrarily recurse into a tree or whatever. It doesn't work that way. It's just literally flat. And that makes it safe and not introducing some of these kind of potential problems that I didn't want to think about. But also, the real reason why it got implemented that way is because it was just necessary to do if we wanted array literals, right? Like, what else would you even do? You need to know a type for the array literal, and you need to type check the elements. And then if we want to enable you to not have to explicitly state the type, how would that ever work? Well, you just need to figure it out and then apply it to the elements, right? With struct literals, it's a little scarier because you have recursion in there. But again, it was what was necessary to make it happen, right? And so like without that at all, you can't ever have struct literals unless you explicitly write the type, right? So that's all, is just that with these other cases we're talking about, it's not as necessary. It's more of a mild inconvenience in some cases, which is why it just hasn't been a thing. But like I said, you asked about Mac, any roadmap. So we sort of have Mac behind the scenes. And I didn't want to officially distribute it because once we do that, we're sort of committed to keeping it working. And there were two things about that. One was there was this very inconvenient timing with, Apple's, well, there's multiple things. There's the inconvenient timing about the CPUs. And then the more ongoing issue is because we don't want to support two versions of the compiler for Mac, right? But then also just Apple makes breaking changes every time they release an OS, right? And so then every freaking time they release an OS, it's like we sort of have to support both over the interim, and that sucks, right? They're not like Windows, which at least used to try to maintain backward compatibility very well. They're not as good at that now, but the point being, because we used to be a little more manual about the process of building different operating systems and making sure they stay working, it was harder. Like those combinatorics were more painful. Recently, Raphael did a better build system. So now, we have different machines running different operating systems and coordinating the results of each build. And then we get a summary of each build. And that is way better for this kind of issue. And so we were sort of waiting on that, and that's new, right? And so now the question is just, when do we feel like we could do Mac. And I don't know. Could use bytes to add a replacement for compare and swap on ARM. Oh, that's a good point. That doesn't allow us to support arbitrary. The reason I was thinking of it for LLVM was just because then also it could do any other wacky CPU, like the mill or something, but maybe that's not, or you know, what do you call it? RISC V. But yeah, I mean, to solve this short-term problem and just help the beta people out so they don't have to edit this file, we absolutely could do a bytes directive. If one of you guys doing ARM wants to tell me what that is, I'll just put it in here. The only other ingredient is just being able to do the static if. And then I kind of feel like maybe ASM should be combined with static if in some way. Like maybe you could put a condition here, right? I don't know. Because, I mean, maybe this is stupid. We don't need to do this right now, but I feel like we're going to have this thing with a lot of static ifs with ASM inside, but maybe that's fine because maybe there would be more than just the ASM inside the static if, and so it doesn't make sense to do that. All right, I got like 1 minute, 2 minutes. I'm glad you're enjoying the beta. Thank you for the positive comments. I imagine it's a self-selected audience because people who don't like the programming language and they get the beta, they just don't participate and ignore it or drop out. And that's fine too. We're not trying to make a programming language for everybody. We are trying to make a programming language that fills a niche that is not currently being filled by other languages. So if you enjoy it, I think that's great. We're still working hard to make it the best that it can be. You didn't mean to push the videos too hard. No, I get it. And I get why you're asking for it. It is fun to do those videos, like back when I did the demo videos. It's just, it is a lot of effort, and it just turned psychologically nasty when I felt people were abusing me via the videos. And so, yeah, like I just feel personally abused, and so I don't like to do them for that reason. Because you put in all this work and you get negative reward for it, and it's like, well, GG. What about ASM like if equals case x86? Yeah, that would make sense too. It's just the question is how good of an idea. Like, does that handle, like I would rather do it without the syntactic sugar and then just see how many cases would be completely covered by that kind of syntactic sugar. All right. Thank you, everybody. I got to go. I have a meeting now. But it's been fun. We'll do another one of these if people have more questions. Thanks for participating. You can, of course, follow up. People in the beta know what email to follow up with. So if you have, you know, more, if you have more in-depth questions or more tweaky questions that most people won't care about, or you want elaboration on some stuff we talked about here, you could post in the Discord. You could email. And we will follow up. Thank you. We'll post this on YouTube probably before too long. And if you missed parts of it, you can catch it. Thanks. Thanks everybody on Twitch who showed up, and have a good day. I was going to say afternoon, but I was going to say weekend. I don't know. I was going to say all these things. Goodbye.